up front.
I didn't understand any of 6, so I doubt I'm going to understand any of 7.
So a parabola is the graph that comes from a quadratic equation. We'll just write that, then I'll show you an example. Graph that comes from quadratic equations. Alright, so if we're looking at what it is, a parabola is something like this.
Not these.
Yes, these.
Oh, the face. Oh.
Right? Not each one is a different parabola. This is one, this is one, this is one, this is one. All it is it's a right side up U or upside down U shape on the graph.
Well, wait, will they give us points?
They will. Yep. So you guys remember how last chapter we had certain things like the x squared functions that gave us these u's?
No.
Right? Where we made the table like x squared plus 4, and you'd make a table and you'd plug them in and you'd get this funky little u.
Whenever the exponents came up, I just did the exponents on the thing by the x.
Interesting. Yes.
At the end of the word parabola, is that an A or is that a U?
This one? Oh, that's an A.
Okay.
Okay, so a parabola is the right side up or upside down U. It's the graph. Okay? Next thing is we have the axis of symmetry. Symmetry. Alright, so each parabola has a line that goes down the middle to where both sides are the exact same. Or just the line, oh no, the line down the center of a parabola. And we'll just leave it at that.
Why are math names so weird?
Yeah.
Because all the other good names were taken by
What?
language people.
Oh, but what?
Tiger.
No. Not that.
What do you mean, what name?
Guys, look.
Well, we have parabola, we have axis of symmetry. Like, also, English is just a weird language.
Yeah, we know.
It doesn't make any sense.
That's why we should switch to a different one.
Like what?
I mean, I agree
Not
with that.
Spanish.
I mean, Spanish would be the next one because it's the most unilaterally used across all the countries.
Really? I thought English was.
English is the international language, but Spanish is used as a base for Italian. You could also use Spanish and French, as well as Portuguese and Spaniard.
So which one is more used, English or Spanish?
English.
We rule.
Yeah, but that's because us as America kind of made everyone.
Yeah.
We're dominant.
Well, and Britain, sorry, and England. Because England was they ruled, you had the England Empire for a while, and they forced English to be the universal language, and then we split off from England. So it's like us as the military superpower of the world and the biggest Hollywood creators. We create like 98% of all media that is released throughout the world. So movies, songs, everything. It's all in English.
Really?
Yeah. Like we dominate the entertainment realm.
Yeah.
It's nuts. Anyways, moving forward.
Wait, what is
I didn't know
it?
that.
I'm trying to...
The line down the center of a parabola. We then have a quadratic function.
This is something you can't see.
Uh-oh. Quadratic function. So a quadratic function has the form, or the exponent has a square over it. So for a does not equal 0, the function y equals a. Okay. So where a does not equal 0, then y equals a times x squared plus b times x plus c.
Let's say AX.
A x times x squared. Okay, what this looks like is if you had actual numbers in it, you could have y equals 2x squared, right? We've seen something like that before. Or you could have y equals x squared plus 2. We've seen something like that. Or something new, but in the same world, y equals negative x squared minus x minus 3, right? I think the only one that we haven't seen is this one because there's an extra x there. Because whenever an x has an exponent, you cannot combine it with a variable with a different exponent, ever. So if you have x to the third and x, just x on its own, you cannot combine them. They have to stay separate because they give you two different values. So a quadratic equation is basically whenever there is a square root or a square over a variable. And last one for now, and then 3 more later. Oh. Yep. Is standard form. So when a quadratic function is written in the form y equals ax squared plus bx plus c, it is in standard form. When a quadratic function is written in the form y equals ax squared plus bx plus c. So when in order, when it goes highest exponent variable, next lowest variable, constant, okay, that would be standard form. Okay, you would put them in chronological order according to the exponents. Okay, so here you have x squared, then you have x, and then no x. Standard form.
Are we still doing that x squared equals u thing a long time ago?
X squared equals u?
Like
Oh, yes, that is the parabola. You remember how we were trying to say, we had the
yeah.
right, the graphs? The is the parabola.
Okay.
Yep,
Then
so
when we see x2, just know that that equals u.
yes, that means that our graph will look like this. Okay, you remember this, the S1?
Yeah.
That means that there is an exponent with a third power, right? And then each time it goes up, odd numbers, there's always a tail that goes up and a tail that goes down. Even numbers, they both go the same direction. We'll get more into that later. But
So I don't know how to do those. It's like,
well, that's why we're here.
okay, but I thought you said we learned some of that last.
No, we just learned what the graphs would kind of look like, get an idea.
Oh, okay, because I was like,
Remember, we learned like what the absolute value graph would look like, a V, what a quad or the x squared, it would look like a U, right?
And then straight line.
Mm-hmm. And a straight line. So, what is A?
what? Huh?
Are we just like making up a number?
Well, I'm just asking, what do you guys think A is?
A, oh, is the equation?
Nathan?
1,100,000.
No.
I wanted to make it something complicated, okay?
Any number what?
Oh, any number not equal to 0.
Not equal to 0.
Exactly, I was had to have.
A cannot equal 0 for it to be a quadratic function, because what happens if A was 0?
Then it would be 0.
Correct. And then would it be a quadratic function or just a regular linear function?
Regular.
It would just be a regular linear function, right? Because, right, what makes it a quadratic function is this first part right here. You cannot have these two parts and have this, and it's still a quadratic function. However, if you get rid of that, it is no longer a quadratic function. It is now a linear function. Then if you get rid of these two, you have a line.
Nothing.
You have nothing. You just have what y equals. Just a straight stinking line.
But straight lines are cool.
I mean, they're easy, yeah.
I like that.
That's
Okay.
why they're fun.
So, if we have an equation, or a quadratic function, okay? Let's say I give you y equals 3x2, not exactly. 3x2 minus 2x plus 5. What is the a?
The A. Wait, what?
3.
3. What is the b?
B is 2.
Is what?
2.
Negative 2.
-2.
2.
Right.
I'm like so confused.
What is the c?
5.
5. So if they ask you for what is the a, b, or c, this is what they're looking for. They're looking for the number in the equation that represents that. Okay? And if you need to, always look back and be like, okay, which one? Okay, it goes a, b, and c. Okay, makes sense. But b is always with the variable with no exponent. A is always with the variable with the 2 exponent. And c is always the one that has none. So if we had an equation like y equals 3x squared, a would be
3.
3. What would b and c be?
Nothing.
0.
Thank
We
God.
just do.
Huh?
We just do.
We're just identifying what the a, b, and c is, right?
How did 2 and 5 become 0?
Well, no, we wrote a new equation, right?
Okay.
Because there is no 2 and 5, right? There's no b and c. Okay? So that's, if you see something like that, don't get shocked. It's what they're asking. They're just asking you to identify what the constant number is in front of the variable. Alright? So, we are going to make a graph.
Ew.
Yay! And a table.
Those things. No.
Example 1. So we're going to make a table of values and graph the quadratic function. So, make a table and graph of y equals 2x squared and y equals negative 2x squared. Alright, so first things first, I'm going to start by making a table. 2, 4, 6, 7, 8. We'll do that. Stinking love lined notebooks. Without lines, I'd be in so much trouble.
Why?
Because none of my lines... Look at that's why. My lines would not be straight.
How?
Don't wow at me.
I said how.
I got distracted.
Why?
I looked over my own thoughts. I went over to Miss Jansen's class and she had the whiteboard, like a whole paragraph written out on the whiteboard, and literally all of them are completely straight and wonderful handwriting. I'm like, I feel very self-conscious now. I used lined paper.
To be like, anyway.
I was doing it on the whiteboard yesterday, the pie stuff, and I literally had the area over here, the circumference over here, what C is over here, and they're like, I don't understand it. And I was like, this is my brain, guys. I don't understand it either.
Yeah, I was showing Daniel how to do it. He's like, how'd you get the radius? So I'm like, Daniel, here's 10 steps how to do it.
Yeah.
Now show me how to do it. He's like, okay, so this is circumference. I'm like, you don't even know it yet. How do you get it? So.
Oh, I love it. All right, so we have x, and then we have the two equations, okay?
Oh, I hate that line.
X is we're just gonna start at -3 and go up because this is easy, and we don't want the whole graph. We just want a general idea of it. So first things first, okay? We're taking each of these x's and we're plugging them in for x. So we have to do the exponents very first, right?
Yes.
Because it'd be 2 times x squared. Exponents always first.
Negative 2, negative 1.
Yes. Because we're graphing it, so you always want 0 in there because you want to find the middle, and then the other sides doesn't matter. Up to you. So -3 squared becomes 9, right? Because negative times a negative equals positive.
Yep.
And then times 2 would become 18.
Yep.
2 squared is 4, times 2 would be 8. 1 squared would be 1, times 2 is...
Wait.
What?
What? Never mind.
You want to try that again?
I thought you had 4 instead of 3.
No. 1 squared would be 1 times 2 is 2. Plug in 0, you get 0. And then this will be the same thing?
Yeah, it's the
Yes.
same thing all the way down.
Yep, so they copy on both sides. Now with the negative, it's the exact same thing except negatives. Because you're multiplying a positive by the negative 2. Yes, Nathan?
How was -3, -2, and -1 positive, or is that because of the?
It's because of the exponent.
Okay.
Because you get -3 times -3, which becomes a positive 9, and then you would multiply it by 2, which would give you 18. On this one, though, you're doing the same thing. -3 times -3 would give you positive 9, but then you're multiplying by a -2, which then makes it a negative answer. Yes, Mr. Xavier?
So it has the x column is there for -2, 1, 0, 1, 2, 3, and then the next two columns is that like that's the y, and if you put that there in the graph, it'd be 3, 18, and then it would -3 and 18, and then -2 and 8. You would just
I'm sorry, phrase that again?
so
Yeah,
the x-
this would be the y,
yeah,
this is
y,
the x,
and then
yes.
you would just put it on the graph. And it would
Yes, and that's what we are doing next.
Man.
I heard what you said, but I was trying to process it and put it all together, and then I did it as I told you to say it again. So if we were to graph this,
Oh, we're clapping now?
we have all the x's, and these are both the y's. Okay, so for the x's, I know what I want, straight up 1, 2, 3, 1, 2, 3. But going up, I want to get at least 18, so I'm going to go
2, 4, 6, 8, 10, 12.
Or you can do 4, 8, 12, 16, 20.
4, 6, 8. Yeah, we'll probably do that. 4, 8, 12, 16, 20,
12, 16.
-4, -8, -12, -16, -20. 1, 2, 3. -1, -2, -3.
Wait, what? Wait, 20, 16.
You could do whatever scale you'd like. If you made your graph bigger, you could change it. This is just so I could fit all mine. This line is color coding, so
We can't see color.
Yeah.
you can't, but I can, and it's pretty.
Colors that.
I wish we had a better.
Why can't this show, like, is it
It's
just-
the projector.
It's just a projector.
It's not HD and bright.
The projector's colorblind.
Or
I
it's
also-
just old and it's like white to black.
Man.
Yes, exactly. So, first things first, we're going to graph these. We know 0 is 0, 0.
You know,
Okay, -1 is 2. -2 is 8. And -3 is 18. Same thing on the other side. 1 is 2. 2 is 8. And 3 is 18. You then connect them.
You.
Boom. Gosh, it's probably the best graph I've ever made.
It probably is.
It looks a little like
This said is this side's like, oh!
those were up.
Same thing for the other side, except everything's negative. 1 is -2. -2 is -8. And -3 is -18. Yes. Oh my god.
Wait, where'd you get those lines?
I just connected the points. These points. Because you got -3
oh wait, you just connect them.
is 18. Yep.
Oh.
You got -2 is 8. -1 is 2. 0 and 0.
Well, I know that, but those lines in negative.
These ones?
Yeah.
Oh, I'm doing that with this one now. I just haven't connected them yet.
Oh, yeah.
This is not a graph. I don't like it.
Oh, goodness.
Well, it doesn't seem too terrible.
Wait,
It's not super terrible.
are those? what X is? The 1, 2, 3. Is that what X is?
It's a ball.
Yes, these are the x's and these are the y values for the two different equations.
I feel stupid because I wasted my time doing this
This
for
dot
X.
isn't even touching the
Oh, gotcha. Yeah, you didn't
now
need to
I'm
do that.
barely gonna need it.
That'd just be a really cute graph. It's gotta be really skinny.
Yeah,
That's all.
it's gonna be like a V, an actual V, not you.
Alright, so we have these two parabolas, okay? Since each 0 is at 0, 0, and the 0 is directly in the line, we have this beautiful line down the middle that is the axis of symmetry, which means everything to this side is the exact same as everything on this side of the axis of symmetry.
You want to see my chromosome?
Xavier!
God.
Science.
Moving forward.
It's so.
special levels above this time.
Why is it so wide?
I don't know.
Hey, don't judge his graph, because when you judge his graph, it's judging my graph, basically.
Yeah, we're the same graph.
You mean you're
Can I continue looking at that? Wait, I don't need it.
Nope, yeah, you have your table. Alright, so now we have the 3 more vocab words. Vertex.
More.
3 more. Remember, beginning of chapters, you always... You okay?
Yeah.
Beginning of chapters, you always have a lot because it's introducing a new thing. Vertex, the highest or lowest point on the parabola. Highest or lowest point on a parabola. So for the example 1, the highest or lowest point on the parabola, that would be the 0, 0 for both of them.
Why?
It's the point at which,
How come this high school?
it's highest or lowest. Because if it's negative, right, it'd be the highest. But if it's positive, it'd be the lowest.
I see.
It's the point at which it goes and starts its upward turn.
Oh, that's what it's talking about.
Yes.
Oh, that's always, is that always going to be 0, 0? Or is,
No, it's gonna
not
change.
always, but
So
this one is.
it's just where it starts to like.
It's where it it's right at the bottom of the U. The bottom or top of the U
Gotcha.
of the parabola. Right? If you're throwing a ball in the air, it's that point at which it stops going up and starts coming down.
Yeah.
Like an apex.
Okay, so like everything you throw creates a parabola. You may not see it, but it makes a parabola. And the vertex would be the point at which it goes.
Do parabolas, can parabolas just be a straight line then?
No.
But what if it goes straight up perfectly?
It would still be a parabola, just be very, very, very skinny.
No, what if you like it just like perfect line, like straight, this straight.
You can't get that.
You sure?
Yes, there's still microscopic parabolas.
Did we test that?
Based on the air displacement, you're wrong. Minimum value. Minimum value. Alright, so the minimum value is when the parabola opens upwards, the y-coordinate of the vertex is the minimum value. So the vertex for a...
This response to me show you my beautiful graph.
Nice, dude. The vertex for an upward facing parabola. So you have a graph, you have a parabola.
Are they having a fight?
It's none of our responsibility. So right here you have the parabola. This part is both the vertex and the minimum value.
I don't think that's exactly where it is.
It's in that area.
I think she's like.
She said.
Maximum value.
Yeah.
Maximum value. Maximum value is the exact same thing except the opposite. It is the vertex for a downward facing parabola. Yes, but these are basically all the vocabs that you'll need for most of the
I think
chapter.
I'm going to understand this.
You'll use them throughout all of it. It's just understanding the Chapter 7 jargon. Jargon is specialized terminology for a specific thing. The vertex for a downward facing
Oh gosh, no, we have a whoa.
parabola.
Look at all that.
Look at all what? What page are you looking at?
I'm at 465. This is 10-1 actually. Never mind.
Yeah, there's 10 chapters total. But we're only doing 3 of them.
Man,
Including 7.
So far. Okay, let me go look at my first notebook. What did we do? Oh yes, we were trying to figure out.
I remember those days.
Oh, that's when we were doing warm-ups.
Yes, it was, and then I gave up on that.
Plots. We were
Oh,
doing line
wait, we
plots.
stopped warm-ups. When did we stop warm-ups?
When we started grading our own homework.
Like,
No, I think we started. I think we stopped warm-ups. Yeah, when we started grading our own homework, and we also started at the same time doing more problems.
Yes, more homework problems.
Yeah.
And we stopped doing practice problems. I think that was at the change of the semester.
Yep, the good days.
Yep, the good old days.
PEMDAS.
We were reviewing PEMDAS.
Oh, can we
That's
go over
kinda
that? That's like, I
stupid.
think I forgot.
parentheses.
Look it up.
Yeah, what is this? I don't even know what we were doing here.
Multiplication.
We were doing
Equations of aging.
Plan A and Plan B. Man, I have bad writing.
So example 2, it has 3 different graphs. Okay, all it says is you're comparing the widths of the graphs. Okay, you're graphing them using the graphing calculator and you're comparing them. Okay,
Wait, no!
it has nothing I want to write on it. I'm just going to show you. Here, you have 2 different graphs. Y equals negative 4x squared, y equals 1/4 x squared, and y equals x squared. Okay. What do you notice about the graphs?
Nothing.
What is an observation you make between the equation and the graphs? Yes.
One's more like, one's,
Yes.
One's,
Now the one that's what is different between that equation and the me?
One's thicker and the other one's skinny.
Mm-hmm.
One's fat and the other one's not.
That's fine. What?
So, graph shaming?
Yes.
Okay, if you look, there are the widest one is the one with the smallest constant, right? 1/4 is the smallest a, the number before the x, right?
Constant?
Yes. It's the number. Remember when we went over linear numbers? The number before the variable is called the constant.
So the bigger
I
the
know.
number you have, the
Skinnier.
Wait a minute.
Yes, the smaller you have it, the bigger it's going to be. Because what's happening is you're taking, let's say we took 2. 2 squared is 4 times 1/4 gives us what?
Oh wait, say it again. I realized we could solve it.
2 squared becomes 4, so 4 times 1/4 becomes
2. Wait, yeah, 1.
Wait.
I don't
Is
know
it
what you
4 or
said.
1? Cause
Did you wait? 2 squared is 4,
uh-huh.
and then that times that is 1/4. That's 1.
yeah. Would it be 1
Mhm.
or 4?
Yeah, so it'd be 2, 1, right? So then if you did that and continued going, your graph gets wider and wider because the x, it's growing smaller, right? It's got a smaller growth rate. Whereas 4, if you did 2, you'd have 2 squared, which is 4, times 4 is 16. So your x is 2 and your y is 16. That's why it's so wide and so skinny. Because the smaller the constant, the smaller the a is, the more it has time to gradually grow. The bigger that number, it's like, nope. Yes, Hannah.
Can you end up making a circle with one of these graphs?
Yes, absolutely. It's awesome.
Show me.
No,
We have to learn it.
I don't think you guys will. Calculus, though, you'll mess a lot with creating circles with graphs. I actually looked at that yesterday, and there's an equation that you can make an actual circle with. It's pretty cool.
Easy, just like you make that and then you make the other side of it. Just
No, then it's it'd be an oval.
Calculus will be.
Say what?
What grade will calculus be?
Well,
Wait,
it would probably be your junior or senior year. Because if you guys take geometry your freshman year, you'd have geometry, algebra 2 trig, and then you could go into calculus.
That's algebra.
You
Yeah.
have to worry about it for a while.
Correct.
What about being
Trigonometry?
Yes.
What?
Trigonometry is a sister math to geometry.
Is it?
Oh, okay.
I found geometry easier than trigonometry, but a lot of people find trigonometry easier than geometry. I'm a visual learner, so the shapes and me got along really well. Trigonometry is not so much shapes. Yes.
What is trigonometry?
Trigonometry is a mathematics on like the unit circle. What is
All I was told is that all I need is 2 years of math. Okay, I'm pretty sure that's all.
sweet? Finish with algebra 2 and trigonometry, you'll be good.
Yeah, that's all I'm gonna
Calculus is not required. It is an extra math class if you choose to do it.
Let's go.
Yeah.
I just want to do a bunch of extra classes.
Yeah, so your junior and your senior year, you wouldn't have to take a math class. Okay.
Huh?
So, you guys ready for your homework?
No, I have
Yes.
yet to finish writing down the maximum.
Keep in mind that this takes a while
It's right
to
there in
do
your
per
book.
problem, and there's about 39 problems.
Don't tell me what to keep in mind.
Can you
Maybe
have us
they
at
might
least
be-
do 18 of them? Then?
Hmm?
18 problems.
I haven't.
Mr. Swanson, I won't
Do we
judge you.
do-
It still looks like a
Something
chromosome.
that's over
18.
Mr. Swanson,
Huh?
We do
I won't judge you. It still looks like a chromosome.
Exactly, it's just a smaller
There's
one.
not 30,
It's way better though.
No, that's like almost.
Can we do all of it?
Can we just go?
Can we do every single problem?
Yeah.
Go
Let's see.
You guys are bad at negotiating.
No, we just want to do math.
Actually, I think they're pretty good at negotiating because they're getting what they want, right? You need to get more homework.
They're not.
Could you?
Yeah, how about give us 12?
What do you mean it takes long to do these problems? Did you even look at them all?
No, okay.
Yeah, yeah. Oh, you're but
One before it's just like -1.
the only ones that will take long are 9 through 16.
Okay, then make us do 9 through 16.
No, I don't want to do these ones.
No, you guys are gonna do
I
no.
want to get at least some of them right.
9 through 16.
Please, almost please, rubber band normal.
No way.
Yes.
When you're done writing that down, can I see the rest of the?
Yes, you may.
I don't understand what it wants me to write.
Magic school
For
bus.
maximum, minimum
Yeah,
value.
Please let the
Yes, I got you.
field trip.
Well, maximum
I bet you guys
specifically because I've been.
All right, 1 through 39 odd. Yes.
It's not Monday.
You did.
It's because I saw pie and I was like, oh, pie Monday. Wait.
Hi.
Mr. Sorensen.
Yes.
Okay, so
Yes, because I've never made a mistake yet.
1 through 39.
Odd.
I should probably write that so I don't end up doing all.
Which means 18 problems.
I'm gonna figure
okay,
that out.
that's
I don't know that.
There's like 3 of them that should take time. You have to make a table and then graph it. The rest of them are pretty straightforward.
It's still not that hard though. It just takes time.
It just takes time. The rest of them, though, it's pretty straightforward. It's identifying the A, B, and C of the equation,
Yeah.
putting the equations in order from smallest to or skinniest to widest graph, right?
Are we
Remember, the
making?
smaller the constant, the wider the graph.
And I'm saying easier right now so I get them all wrong.
You got it. All the answers are in the back of the book, so
Right.
check your answers. Ready, steady, go. You guys have 10 minutes.